Hi, we are from Team A and we're gonna go through tutorial 4. The question states that a 65-liter cylinder of methane CH4 received from a gas distributor with a pressure reading of 3015 psig and is placed in a 60-meter cube storage room. After 4 days, you notice that the pressure reading decreases to 2688 psig, indicating a leak. Since the storage room has good ventilation, no gas smell was detected. The average room and gas temperature in the cylinder is 32 Celsius and the total pressure in the room is 101.325 kPa. Before we proceed to the question and calculation, we need to draw our process diagram. Firstly, we need to state our basis, which is 65 liter of CH4 in cylinder. In initial state of methane, the initial pressure is 3015 psig. Since our process is in closed system, so there is no stream in or stream out. After 4 days, the pressure of methane decreased to 2688 psig. Other than that, we need to state the volume of the room, which is 60 meter cube, temperature of the gas 62 Celsius, pressure in the room, which is 101.325 kPa.
Question A. Calculate the molar flow rate mole per hour of the CH4 lead after 4 days. The CH4 pressure in the cylinder is too high to be considered as an ideal gas. So, this question stated that we need to find the molar flow rate and then we need to use a real gas equation due to CH4. So the formula is PV equal to Z and RT. So, in order to solve equation PV equal to Z and RT, first we need to find Z value. So, in order to find Z value, we need to have PC and TC. So, we follow step by step. Given of the first pressure equal to 3015 psig, the pressure value is in P gauge. So, we need to use the formula of P absolute equal to P gauge plus P ATM. Since the given value is in PSIG, we need to change it into ATM. So our final value of P absolute is 206.16 ATM. The given temperature in the cylinder is 32 Celsius. First, we need to change it into Kelvin. And then, after we change it into Kelvin, we got the pressure value and the temperature value. And then, we need to find TC and PC. So, by using table B1, for the CH4 value of TC and PC, TC is 190.70 Kelvin. As for PC is equal to 45.8 ATM. And then after that, we use the formula PR equal to P1 over PC and also TR T over TC. And then after we put the values, for the PR value, we will get 4.50. As for TR is equal to 1.60. Based on this value, we will get that the Z value for the methane gas at specific temperature and pressure is in 0.85. Since we already have the Z value, we can calculate the mole value. So by substituting this value, the pressure value, volume value, Z, R and T, we will get 629.89 mole.
The 96 hours, which is 4 days, the pressure decreased to 2688 psig and temperature is still remain constant, which is 32 degrees Celsius. First, we use the same method as we find the number of mole in pressure 3015 psig. Finding the absolute from we convert the psig to ATM to 688 psi over 14.696 psi equals to 183.91 atm. So then we refer to table B1. For CH4 the TC is 190.7 Kelvin, and for the PC is 45.8 atm. To find DR, we need to calculate T over TC, which is 32 plus 273 Kelvin over 190.70 Kelvin. Then we will get 1.6. For the PR2, we need to calculate P2 over PC, which is 183.91 atm over 45.8 atm. Then we will get 4.02. So referring to the graph which is given, okay, we refer to the horizontal axis. We approximate the 4.02 is around 4. Then we looking up to the dotted line, and it will intersect at the line DR equals to 1.6, and then we refer to the vertical axis, then we will get 0.85, which is the same. Okay, then we use the real gas formula, which is PV equals to Z nRT, N equals to PV over ZRT. Then we will get calculate, then we will get 597.03 mole.
So since we already got the N1 and N2, then we can calculate the total leak. So for the total leak formula is N1 minus with N2. Then we can get the total leak is 32.86 mole. Next, to calculate the molar flow rate methane leak, we can just divide the total leak with um, the total leak with 4 days. But be mind that 4 days need to change with the hour, because it says in the question that it needs mole per hour. So 4, we do conversions here. So 4 times with 24 hour, then we'll calculate the molar flow rate. So we get the molar flow rate of methane that leak is 0.3423 mole per hour. So for question B, if the storage room is poorly ventilated, methane would accumulate and mix with air in the room. A mixture of methane and air is capable of being ignited if the mole percent of methane is between 5% and 15%. Would the methane air mixture be ignitable? Explain your answer. So for this question, we need to first identify whether it is ideal gas or real gas. So in order to identify, we can use the V ideal formula, which is V ideal is equal to RT over P. So and then we can sub in all the known information, and then we got the V ideal is 25.03 liter per mole. So since the rule of thumb says that the V ideal needs to be greater than 20 liter per mole to assume that it is ideal gas, then we got the V ideal, which is 25.03 liter per mole. So then we can assume it is ideal gas. And then we can use the ideal gas formula to find N total, which is N total is equals to PV over RT. So we sub in all the known information. We do conversions here, and for volume we use the storage room volume, which is 60 meter cube. Fractions formula, which is mole fractions over mole fractions is equal to mole leak over mole total times 100% to get the percentage mole fraction in percentage. So since we know the mole leak is 32.86 mole, we can just sub in into the N leak formula. and then over with the N total that we got just now, which is 2397.29 mole, and then times with the 100%. Then we got the mole fraction for methane is 1.37%. So the answer is no, the methane air mixture would not be initable because the mole percent of methane is 1.37% and it's too low to reach 5% and 15%. So that's all for our group presentations question. Thank you. Bye bye. Assalamualaikum.